In this video, I'm going to look at solving some simple equations, sometimes referred to as one-step and two-step equations. And I'm going to use this idea of scale to reinforce what I mentioned in my last video about equality and how it's really important for whatever is happening on the left-hand side of the equal sign to actually do equal to what's on the right-hand side. So let's look at some examples of solving equations. Now, this word solving is really important. Let's say the equation says solve for the unknown. So we're not evaluating, even though we're finding a value answer, we're not evaluating as in putting a number into a calculator, some numbers, and getting an answer. We actually have a problem. Our problem, for example, could be x plus 3 equals 11. Now, there is a unique x value which makes this true. If we find that unique x value, then we have found the problem of what plus 3 gives me 11. Now, I can do that without much effort, without needing to know how to do algebra. I can count. I also have an understanding that if a number plus another number makes an answer of 11, then the opposite to that process is, well, if I take away the 3 from the 11, I'm back where I started. So if you have that intuitive understanding, that's brilliant, because that will go a long way in being able to answer more complicated questions. But we want to now put on paper those steps, the process of how do we get to that answer, so then we can apply it to other questions. So I am going to put my scale here, and I'm going to make use of the scale with this easy one, just to start building the notion of how we do the same thing on both sides. So we're starting with 11 on the right hand side. So I'm going to imagine you're pouring some sort of oil and it represents the number 11. Maybe we should do that top of it smooth. And then on the left hand side of my scale, I have x. We always start with x as the first thing that goes into our cylinder. So we have x, and then we are adding 3 to it. So I'm going to write plus 3. And the idea is, if I'm going to keep that scale, that equality true, that scale balanced, if I do something on the left-hand side of the scale, I need to do the same thing on the right-hand side. So if I want x to be the only thing that's on the left-hand side of my scale, then I need to undo the plus 3. And we know the opposite process to plus 3 is minus 3. So if I take away 3, that will remove the 3 from here. The 3 comes out. We've taken it away. But that will create an imbalance. So I need to take away 3 from here as well, which results in, on this side, I have 11 minus 3, 8 left over. So that's a pictorial way of representing it. In terms of mathematics, the step is take away 3 from both sides, and I'm left with x equals 8, because 11 minus 3 equals 8. So that's a really straightforward one. Let's look at another one. Let's say I have 15 plus x equals 25. So again, I have an intuition that, well, 15 plus 10 gives me 25, so my x needs to be 25, but I am going to actually do the same process with the scale. So we have 25 on the right-hand side. We always put our x in first, and then to my x, that's a positive x, I am adding 15 to it. And then to undo that, because we are adding 15 to x, we have to do a subtraction. So we do a subtract 15, and we do a subtract 15, and that will leave me with 10. Mathematically here I would write minus 15 on this side, minus 15 on this side. That leaves me with x equaling 25 minus 15, 10. Let's do another one of these one-step equations. Let's say I have x minus 6 equals negative 4. Now, negatives sort of make the mental arithmetic harder, but in terms of actual mathematics of it, it's no different whatsoever. So I'm going to go through that process again. On the left-hand side, I have minus 4. On the right-hand side, I have x. We always put our x first, and then we're taking away 6. That's what goes in second. Now, because negative x is on top, I need to undo that. I need to remove it so that I'm left with just the x. So to do the removal of negative 6, I need to add 6. And I need to add 6. So the opposite process to minus 6 plus 6, and I'm left with x equaling negative 4 plus 6, 2. So they're referred to as one-step equations, and they are our introductory to equations. Let's now move on to two-step equations. Let's look at something really straightforward. 2x plus 1 equals 5. Something really easy as a starting point. And then we might jump straight into something a little bit more challenging. So on the right hand side in my scales, I have plus 5. On the left hand side, we start with x. Then order of operations tells me do the multiply before the addition. So the next thing that goes in is 2. And then the next thing, that's multiply by 2. And then the last thing that goes in is plus 1. So if I'm going to remove everything one at a time out of my cylinder, I need to start from the top and work my way back down to x. So the layer that's on the uppermost is plus 1. So for that to come off, I need to do minus 1, which means I need to do minus 1 here. So minus 1 on the left hand side, let's line them up actually, that will be nicer. Minus 1 on the right hand side. So now on the left hand side I have 2x plus 1 minus 1. The whole idea was to remove the plus 1. So that leaves me with 2x. 5 minus 1 is 4. So now what's left here in the cylinder is 4. And the 1 is gone. The next step is to undo the multiply by 2. So I divide by 2 because that's the opposite. That will undo. That will get the multiply by 2 out of my cylinder. And to keep the balance happening, we divide the other side by 2. So divide by 2, divide by 2. That leaves me with x equaling 2. And I've solved the problem. Let's look at another two-step question. What if I had 4 minus 3x is equal to, say, 25. Let's put our cylinders back in, and then we might do the next one without the cylinders. On the right hand side, I have 25, the right hand side of my equal sign. So just to let you know, we have the left hand side of the equal sign and the right hand side, a little bit like the left hand side of my scale and the right hand side. On the left hand side, we always start with x. Then order of operations tells me do the multiply first before addition or subtraction. Now x is being multiplied by negative 3. So that's actually what's happening. We are multiplying by negative 3. The operation between the numeral and the pronumeral is a multiply, but 3 has a sign of negative in front of it. And 4 has a sign of positive in front of it, so we're actually doing a plus 4. And a lot of students get confused because we tend not to see our equations this way, but we need to remember that negative numbers, the sign appears before the numeral, so the minus goes with the 3 and behaves as a negative. So if I'm going to remove things one at a time, I have to start with the uppermost, whatever is sitting on top, that's plus 4. So I'm minus 4 from both sides. So we're doing a minus 4 here and a minus 4 here. That leaves me with negative 3x equaling 21. So my 25 has now become 21. The next thing to remove is the multiply by negative 3, and the opposite of multiplying by negative 3 is dividing by negative 3. So we're dividing both sides by negative 3. Divide by negative 3. So divide by negative 3 removes this out of my cylinder. I need to make sure I do the same thing on the other side. So that leaves me with x equals 21 divided by negative 3 is negative 7. Let's do one more. Let's say we have 3x minus 6 equals, let's make it 12. So I'm not going to draw my cylinder. We know that everything works in the opposite. So we're doing essentially bit mass in the opposite process. So the first thing to do is add 6 to both sides, because usually add and subtract would be the last thing we do. So, and we're doing things in the opposite order. So that leaves me with 3x equals 18. And then the next thing to do is divide both sides by 3. Now, if that was a little bit too tricky to follow, draw yourself the cylinders, follow the process, and see if you end up with the same result. 18 divided by 3 gives me 6.